1 for each of these. So 1, 2, 3, 4, 5, 5. We have our fifth degree. So f of x, you need f of x. We have this graph and there's an x and a y, so you need f of x over here. If you did not put f of x, we took a point off. So what are my zeros?
X plus 3.
I have -3, so this is x plus 3.
X plus 2.
X plus 2 for my -2.
X.
0 becomes x.
X minus
For my 1, I would have x minus 1.
X minus 2.
And for 2, x minus 2. And that one was worth 3 points. Alright, for 7. Find a fourth degree polynomial with zeros at 2 and -1. Leave your answers in factor form. So what can my answers be? I know my zeros are 2 and -1, so I have an x minus 2
X.
and an x plus 1. How do I make this into my fourth degree polynomial?
Square both.
Square both. Is there another way?
Yeah. Cube 1.
Right, we could also have done x minus 3 cubed, or, I'm sorry, 2. X minus 2 and x plus 1. Or the other way. This could have been left as 1 and this could have been cubed. You do not have to put f of x over here. Since there's not a graph, there's no x and y terms. What if this had said that 2 crosses and 1 touches?
2 is odd and -1 is even.
Okay. This would have to be a fifth degree. Okay? How would I do this one? My zeros are 2 and -1, so I have x minus 2
To the
and x plus 1. What would x minus 2 be?
X minus 2 would be like 3. Because it's odd.
3.
Yeah, it has to be either 1 or 3.
And this one would be
Even so 2.
a 2. Was there any other combination I could have used?
Yeah, you could have used 4 on the.
X minus 2 could have had a 1, and x plus 1 could have had a 4 over here. Alright, look at 8. Find the value of k if x minus 3 is a factor. So I'm going to use synthetic division over here. So I'm dividing by 3. And what are my terms? 1,
-5.
-5,
-k. Plus 18. Plus
18, and 18.
Oh, there's no need on this one.
Bring down my 1. 3 times 1 is 3. Add these. What do I get? -2. -6. Add these.
-6.
-k minus 6. Multiply. -3k minus 18. This becomes -3k. Multiply. -9k. Add these. -9k plus 18. How do I find k?
Set equals
Set this equal to 0.
You set the wrong one.
-9k plus 18 equals 0. Subtract 18 from each side. -9k equals -18. And k equals 2 when you divide each side by -9.
Yeah.
We were completely right.
He
Do this when you see this. Use this way. Okay?
Garbage. Yeah, we were so close.
We were.
Nine. Come on, guys. Let's finish this. Determine if 2 is an upper, lower, or neither bound. So what? How do we tell if something is an upper bound?
All positive.
All positives. And if it's a lower bound,
Checkerboard.
checkerboard. It alternates. Positive, negative, or negative, positive, back and forth. So let's try this. I use synthetic division. So 2 goes into this. So do 1, 2, negative 7, and 20. So when you do this, you get all positives down here. So it is an upper bound. If you did not get all positives down here, then check your math. You might have done a little error. Look at 10. Find all the rational zeros.
Oh my god.
What does that mean? Rational zeros.
Please try checking every possible answer at the beginning so you get the last one.
No square root.
No square roots.
It's fractions and positive and negative.
So first thing I need to find all the multiples of negative 20. So it's positive, negative 1, 2, 4, 5, 10, 20. And then for 2 over here, you divide that by the multiples of 2, or positive, negative 1, and 2.
I have a question.
Yeah.
Would it be easier just to plug in the variables into the problem until you get the remainder of 0 and then do the long division to get all the other things?
You don't have to do any long division in this
Sure.
one. Let me show you.
Stop.
Okay? So here's all my numbers I need to test. I'm going to try 1 first. And 1 ends up working.
Then this one.
Should have gotten 0 as the remainder for 1.
Oh.
Nothing, nothing
Well,
left.
I thought that was
You're supposed to have a cross at 0.
I swear to God. It was so close.
Guys, we're not going to get through this if you keep talking.
Okay.
0 is your remainder if you tested 1. Once you have that, you're left with x minus 1. Okay. Rewrite this. You get 2x cubed minus 11x squared plus 7x plus 20. There's no remainder. Now we look what's inside of here. Forget this. And we do synthetic division again. So we need to test some numbers with the factors of 20 and 2 again. So negative 1 ended up working. You got that? You got no remainder. So then you would have x minus 1, x plus 1. And this would be 2x squared minus 13x plus 20. And then you do synthetic division again. Or you could factor this. Is 2x squared minus 13x plus 20 factorable? Yes. You get 2x minus 5 and x minus 14. So when you solve each of these for x, you get x equals 5 halves and x equals 4. So we have 4 zeros. X 1. This was worth 4 points.
Okay, so
Yeah. 2x minus 5.
Okay, 11. What do I do first?
How close were we at?
Find the multiples of negative 5 and put it over the multiples of 1. This is what you should have gotten. When you test them, negative 1 works.
Yeah, we got to that part.
Okay? You should have gotten 0 as your remainder. Then, this right here turns into x squared plus 3x minus 5. Can we factor that? No. I use the quadratic equation. So you do negative b plus or minus the square root of b squared plus 4 times a times c. All over 2a. This equals negative 3 plus or minus the square root of 29 over 2. So this is actually 2 zeros, because you can either do plus or minus over here. So your answer should have been negative 1 and negative 3 plus or minus square root of 29 over 2.
I did a different way. Yeah.
Well, find all the rational zeros and real zeros. This one was worth 9 points. This was a big one. You guys need to make sure you understand how to do this. So all my multiples of 8 over my multiples of 1. When I test them, I'm using synthetic division. So 2 works. When you do that, you get 0 as your remainder. And we have this is what we end up getting right here. We have x to the 5th minus 0x, 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 so this becomes x to the
This is just x minus 4. 5, 4, 3, 2, 1.
x to the 4th,
Just
Right.
negative 4.
minus 4 right here. And this factors as x squared plus 2 and x squared minus 2.
That should be x over x squared.
You factored out a 0 over, or an x over here. Everyone see that?
Yeah,
You factor out the x, because this has to be a constant.
right.
So this becomes x to the 4th minus 4, factor that.
Is that your rewrite of the plus 2 one? That's synthetic division right there?
This,
Yeah. Is that the rewrite of that?
rewrite of this.
What?
I used synthetic division, I did 2 into this right here, x to the 5th, this right here. I got a remainder of 0, and when I rewrote this, I got x to the 4th
that was just
minus
wrong.
4. And then this equals, when you factor it, x squared plus 4, x squared minus 2. Solve for x for each of these, and you get x is plus or minus square root of negative 2, plus or minus square root of 2. So my rational zeros are 0 and 2. So this x right here is a 0. I have 2 because 2 went in over here. My real zeros are 0, 2, and plus or minus square root of 2. Do not write this one. Yes. And when you factor completely, you get x times x minus 2 times x plus square root of 2
worries.
Alright, last page, real quick.
Don't you still have to keep?
When the multiplicity of a zero is even, the graph touches. So when it's added, crosses through. This was 1 point. Use the graph to answer the question. So the degree of the polynomial function, we count. It goes 1, 2, 3, 4. When it touches, you count it as 2. And 5. So the degree is 5. Is the leading coefficient positive or negative? It's positive. This is going upwards. So it's positive. Name the number of local extremas. That's the same thing as max and min. So this is always 1 less than your degree.
You can just take,
4.
or you can just find the max and how many.
Or you can
does that
count
amount
1,
to?
2, 3, 4.
And then add.
Add one
to
subtract.
Yeah.
That's what I would.
The number of inflection points will be 1 less than your max and min, or 2 less than your degree. This was 3.
Basically just count the level extreme at.
And then that's how you figure out it.
And your zeros are -3, -2, 0, and 2.
Except we didn't put up.
When you factor this, you need f of x again.
We got all those correct.
This is x plus 3, x plus 2x squared. This is even because it touches over here. So it has to have an even power. And x minus 2.
For 14e, would you rather be wrote -3, -2, 0, 2, or x equals for 14e?
E,
Because I would have wrote.
-3, -2, 0, 2.
Yeah. I wrote x equals 3, 2, 0, -2. Like when I was writing them, x
The
minus.
3 is not the answer.
No, like x minus 3 or x plus 3x. Because like on our table we must be different. So like I know then what's the x. And like if I were to write it that way.
It's not a 0. What is your answer, Winston? Winston?
It's touching like the 1, so it'd be x minus 1 squared.
It's touching the 1.
No, if it was,
If it was,
would it be x minus 1 squared?
yes. Yeah, so did everyone hear that? So if this was going like this, and this was 1 over here, you would write this as x minus 1, and it would be squared, because it's an even power.
Thought you could swear any of it. Yeah, you could put the.
You can't square any of them. This, you have to look at, if it crosses, it's odd. So it has to, the number, the exponent over here has to be an odd number. Over here, at 0, it touches, so it's even. The exponent has to be an even number, so that's why we squared that one. Okay, last one, 15. The zeros are -1, 5, and 3. The multiplicity of -1 is odd, 5 is even, and 3 is odd. We determine this by looking at the exponents. So over here, 3 is an odd number, 4 is an even number, and the exponent over here is 1, which is an odd number. And E, it crosses, touches, and crosses. So everyone's ready for their test tomorrow? Study.
I was confident. Yeah, I'm so ready.